Good morning to all. So today I am going to start one important chapter for icse board. That one is calorimetry. Okay. So first we are going to define calorimetry. So what is calorimetry? So it is the branch of science in which amount of heat transfer can be studied when they mix with each other. So what is the meaning of that? Suppose we have two substance. One is liquid and one is metal ball. Okay, in this container we have kept one liquid, okay, whose temperature is 100 degrees Celsius, and there is one metal ball whose temperature is 20 degrees Celsius. So this liquid has higher temperature and this metal ball has low temperature. So when I immerse this metal ball on this liquid, so heat transfer take place, and the direction of heat transfer is from hot body to cold body. Okay, so heat is going to transfer from liquid to water. Okay, this one is the direction of heat transfer because liquid is at high temperature and metal ball is at low temperature. So how much amount of heat is going to transfer? Okay, we are study in this calorimetry chapter. Before going to study the calorimetry chapter, okay, we have to define some term. So our first term is heat. So everyone know that what is heat. Heat is a form of energy which transfer from higher temperature to lower temperature. Okay, suppose there is two bodies. Suppose its temperature is 70 degrees Celsius and it has temperature 10 degrees Celsius. When I join them, so what is the direction of heat transfer? Heat transfer will take place from this direction. Okay, from higher body to lower body. Okay, so this one is the direction of heat transfer from 70 degrees Celsius to 10 degrees Celsius. So this one is the direction of transfer of heat. Now we have to study about the units of heat. So as we know that heat is a form of energy, so its SI unit is joule, and there is one another unit, that one is calorie. Okay, and 1 calorie is nearly equal to 4.2 joule. This calorie sometimes it can be written as kilocalorie. Okay, so 1 kcal. Okay, so 1 kilocalorie, 1 kilocalorie is equal to, we can write 10 to the power 3 calorie, and suppose I convert this calorie into joule, so it will come 4.2 joule. So 1 kilocalorie can be written as 4200 joule. Now our next term is temperature. Temperature, okay, we already know the definition of temperature. Okay, temperature is the parameter which tell us about the degree of hotness and coldness of a body. Now SI unit of temperature is Kelvin. Okay, and there is one more another unit of temperature which we frequently use, that one is degree Celsius. Okay, and suppose I have to convert any temperature which is given in degree Celsius. Suppose we have 27 degrees Celsius. Suppose I have to convert this 27 degrees Celsius into Kelvin, then we have to add 273 to this temperature. So it will become how much? 300 Kelvin. Okay, so this one is the temperature in Kelvin. Okay, so whenever we have to convert any degree Celsius temperature to Kelvin, we have to add 273 to it. Okay, now one important term which I have to tell you, that one is change in temperature, or sometimes it is called as raise in temperature, and it is represented by delta T, or sometimes it in delta T is equal to temperature, final temperature minus initial temperature. Okay, so this one is delta T. Okay, so the look, suppose we have one body. suppose its initial temperature is T1. Suppose I am considering initial temperature. Okay, so T1 is equal to 20 degrees Celsius. Now suppose I supply some heat on this object. Okay, so due to this supply of heat, its temperature is going to increase, and now its temperature become 100 degrees Celsius. Now suppose what is the change in temperature for this case. So change in temperature, that one is delta T, can be written as final temperature minus initial temperature. So it will be 80 degree Celsius. Now suppose I convert this temperature in, suppose I want to convert this temperature in Kelvin. Okay, so in Kelvin scale, what is that? 20 plus 273, so it will come 293 Kelvin, and it for this 100 plus 273, so it will come 373 Kelvin. Okay, so here we have calculated the change in temperature in degree Celsius. Now suppose I have to calculate the change in temperature by taking that Kelvin scale. Okay, then what is that value will come, let's see. Okay, 373, that one is our T2, and T1 is how much? 293 Kelvin. Now find delta T. Delta T will be 373 minus 293, so it will come 80 Kelvin. So what you observe, that whenever we are going to find change in temperature, okay, whenever we are going to find change in temperature, change in temperature in Kelvin scale or in degree Celsius scale, okay, in both cases it will be same. Okay, so whenever in question they will give you initial temperature and final temperature. Okay, suppose they will give in degree Celsius or Kelvin. Okay, don't bother about it to convert it in Kelvin or Kelvin to degree Celsius, because suppose we find change in temperature, then always it will come same. Okay, so change in temperature will be same whether you calculate it on Kelvin scale or degree Celsius scale. So this one is one concept. Now let's study about some other concept. So this one is factors affecting the quantity of heat supplied on a body to raise its temperature. Okay, so suppose I have to raise the temperature of any object, so we have to supply the heat, and the heat absorbed by that body will depends on some factors. Okay, so first factor is it is going to depends on the mass of the body. Now how it is going to depends on the mass of the body? Suppose I am giving you one example. Suppose there is one container. In this container, suppose there is 1 kg of water, and suppose there is another container in which we have 100 kg of water. Now suppose I have to increase the temperature of this 2 water, okay, liquid by same amount of temperature. Suppose its initial temperature is 10 degrees Celsius and its initial temperature is also 10 degrees Celsius, and now I have to increase its temperature up to 50 degrees Celsius, and in this case also we have to increase its temperature up to 50 degrees Celsius. So in both cases we have to increase the temperature by same amount, but there is difference between masses. Okay, so you should tell me in which case we have to supply more heat. Suppose we are supplying heat here, okay, Q. So in which case we have to supply more heat? The liquid which has more mass, because here it has 100 kg. So for increasing same amount of temperature in this 100 kg water, we have to supply more heat. But for increasing the temperature of this water, okay, which is 1 kg, from 10 degrees Celsius to 50 degrees Celsius, we have to supply less heat. Suppose Q1 and Q2. So in this case Q2 is greater than Q1 because M2 is greater than M1. Okay, so through this we can say that the amount of heat supplied on a body is directly proportional to its mass. Okay, suppose if mass is increases, then amount of heat energy supplied to the object is also going to increase. So this one is first factor. Now second factor on which the amount of heat energy depends is change in temperature or raise in temperature. That one is called delta T. Okay, now second factor is change in temperature or raise in temperature. That one is delta T. So suppose we have now two balls, and in this case two balls have same mass 2 kg, and this ball B has also mass 2 kg. Okay, and this one is metal ball for same material. Okay, suppose it is made up of iron, and this one is also made up of iron. So two identical ball of same mass and same material. Now in this case we have to, this ball has suppose initial temperature 10 degrees Celsius, and this ball has also initial temperature 10 degrees Celsius, and suppose I have to increase this ball A temperature, we have to increase up to 50 degrees Celsius, and here we have to increase its temperature up to 100 degrees Celsius. Okay, so in this case tell me change in temperature. Suppose delta T1 will be 50 minus 10, so it will come how much? 40 degrees Celsius, and here change in temperature or rise in temperature 100 minus 10, so it is 90 degrees Celsius. Now here change in temperature is less, and here change in temperature is more. Now tell me in which case we have to supply more heat, in bowl A or in bowl B? Yes, it is obvious that we have to supply more heat on this bowl B, because we have to raise its temperature up to 100 degrees Celsius, and here we have to raise its temperature up to 50 degrees Celsius. So Q, the amount of heat energy supplied on a body, is also directly proportional to change in temperature delta T. So if delta T, change in temperature, is going to increase, the amount of heat energy supplied to the object is also going to increase. So this one is second factor on which amount of heat supply depends. Now third factor on which heat supply to a body depend is material of body. Okay, so every material has some specific properties. So these properties, suppose let's take some examples. Suppose we have one metal ball. Now this metal ball has mass 5 kg. and its initial temperature, suppose initial temperature is, it is at 20 degrees Celsius. Now there is, in one more container we have water, and this water has also same mass, that one is 5 kg. So in this case mass is same, and also its initial temperature is also same. Suppose it has temperature 20 degrees Celsius. Now we by supplying heat, suppose I have to increase this temperature up to 50 degrees Celsius, and this case also I have to increase this temperature 50 degrees Celsius. Okay, so in this case what is same? Mass is same, and also change in temperature is also same for both the cases. Okay, here also change in temperature is 30 degrees Celsius, and here also change in temperature is 30 degrees Celsius. Okay, but here mass is same and also change in temperature is same, but also in which case we have to supply more heat? Tell me. In water we have to supply more heat, okay, compared to this metal bowl. Okay, to increasing same amount of temperature, okay, we have to supply more heat to the water. Okay, so this one is the properties of water, and this properties is we will discuss later. That one is called a specific heat capacity. Okay, so every material has a fixed specific heat capacity. Okay, so the material which have more specific heat capacity, they require more heat to increase its temperature. So these are the factors on which amount of heat energy absorbed by a body depends. Okay, so we have discussed one thing, Q is directly proportional to M, and second we have discussed Q is directly proportional to delta T. When we combine both these two, okay, we will get one relation, Q is directly proportional to M into delta T. Suppose I remove this proportionality, okay, so Q is equal to MC delta T. So this one is one equation, okay, which we are going to use to calculate the heat. In this case, this C is constant proportionality, okay, and it is called a specific heat capacity of the substance. So this one is a specific heat capacity. So before going to define a specific heat capacity, let's define one more term. That one is heat capacity, and it is represented by C dash of in some book it is represented by some other letter, okay, but for ICSE board in Selena book it has represented by C dash. So heat capacity is defined as amount of heat energy required by a body to raise its temperature by 1 degree Celsius or 1 Kelvin. Okay, so this one is heat capacity, and the formula of heat capacity is heat capacity C dash is equal to amount of heat supplied divided by raise in temperature. In short form, it can be written as C dash is equal to Q divided by delta T. So this one is the expression for heat capacity. Now through this expression we can determine the unit of heat capacity. So SI unit of heat capacity is equal to, see, we know that what is the SI unit of heat? Joule. And what is the unit of change in temperature? It is Kelvin. So we can write it Joule per Kelvin. Okay, so this one is the, it can be written as like that also, Joule per Kelvin. So this one is the SI unit of heat capacity. Sometimes they will give this heat capacity in the form of kilojoule per Kelvin. Okay, so kilojoule per Kelvin can be written as 10 to the power 3 joule per Kelvin. And now suppose they will give the specific heat capacity in this form, kilocalorie per degree Celsius. Then suppose I have to convert it in calorie degree Celsius. So what will be its value? 1000. Kilo means what? 1000. Okay, calorie per degree Celsius. Okay, now suppose they will give 1 calorie per Kelvin, and I have to convert this 1 calorie per Kelvin into joule per Kelvin. Then what we have to do? We know that 1 calorie is equal to how much joule? Yes, it is 4.2 joule. Okay, so it will come 4.2 joule per Kelvin. Okay, so from this sometimes ICSE board have asked so many questions from this concept. So sometimes they will ask like that. Suppose a vessel has heat capacity 30 joule per Kelvin. Okay, so they have asked that what it means. Okay, so suppose any vessel or any substance has suppose heat capacity 30 joule per Kelvin. So what is the meaning of this? So meaning of this is that suppose we have to increase for increasing the temperature of a vessel by 1 Kelvin or 1 degree Celsius. Okay, we have to supply 30 joule of heat. Okay, so ये जो वेसल है इसका टेम्परेचर 1 केल्विन या 1 डिग्री सेल्सियस बढ़ाने के लिए हमको कितना हीट सप्लाई करना पड़ेगा? 30 जूल. ओके, सो दिस वन इज द मीनिंग ऑफ हीट कैपेसिटी. कोई भी ऑब्जेक्ट का, मान लो ये एक मेटल बॉल है, मान लो इसका हीट कैपेसिटी है 50 जूल पर केल्विन. ओके, तो इसका मतलब है अगर हम इस मेटल बॉल का टेम्परेचर 1 डिग्री सेल्सियस या 1 केल्विन बढ़ाना चाहेंगे तो हमको कितना हीट सप्लाई करना पड़ेगा? 50 जूल का हीट सप्लाई करना पड़ेगा 1 डिग्री बढ़ाने के लिए. ओके, सो दिस वन इज हीट कैपेसिटी. नाउ वी आर गोइंग टू डिफाइन स्पेसिफिक हीट कैपेसिटी. Specific heat capacity represented by C. Okay, so specific heat capacity, the definition of a specific heat capacity is that the amount of heat energy required to raise the temperature of a body of mass 1 kg by 1 डिग्री सेल्सियस और 1 केल्विन। ओके, सो इसका मतलब क्या है, देखो जो हीट कैपेसिटी था वो डिफाइन था, उसमें हम लोग को मास कितना है बॉडी का वो नहीं पता था, बस कोई भी मास हो उसका हमको टेम्परेचर 1 केल्विन या 1 डिग्री सेल्सियस बढ़ाना है, ठीक है। सो दैट वन इज़ हीट कैपेसिटी। बट स्पेसिफिक हीट कैपेसिटी में इट इज़ ऑलवेज डिफाइंड फॉर 1 kg, ठीक है। मतलब 1 kg वाटर का टेम्परेचर 1 डिग्री सेल्सियस बढ़ाने के लिए, या 1 kg आयरन बोल का टेम्परेचर 1 डिग्री सेल्सियस बढ़ाने के लिए, कोई भी ऑब्जेक्ट जिसका मास 1 kg है उसका टेम्परेचर 1 डिग्री या 1 केल्विन बढ़ाने के लिए जितना हीट सप्लाई किया जाएगा। ओके, सो दैट हीट इज कॉल्ड स्पेसिफिक हीट कैपेसिटी। सो सपोज यहाँ पे मेरा एक बॉल है, सपोज दिस बॉल हैज़ मास 1 kg। ओके, इसका टेम्परेचर इनिशियल टेम्परेचर मान लो 20 डिग्री सेल्सियस है और इसका टेम्परेचर हमको 21 डिग्री सेल्सियस तक ले जाना है, ठीक है। तो इस 1 kg बॉल का टेम्परेचर 1 डिग्री सेल्सियस बढ़ाने के लिए हम जितना हीट सप्लाई करेंगे, ओके, दैट हीट इज कॉल्ड स्पेसिफिक हीट कैपेसिटी। ओके, एंड स्पेसिफिक हीट कैपेसिटी हर सब्सटेंस के लिए फिक्स है। ओके, सो चलो अब इसका डेफिनेशन लिखते हैं, और सॉरी फार्मूला लिखते हैं स्पेसिफिक हीट कैपेसिटी का। सो फार्मूला ऑफ स्पेसिफिक हीट कैपेसिटी इज amount of heat supplied divided by mass into change in temperature. In short form it can be written as Q divided by M into delta T। ओके, सो देखो एक चीज़, C इज इक्वल टू Q डिवाइडेड बाई M इंटू डेल्टा टी। हाँ, इसमें जो Q बाई डेल्टा टी इसको क्या बोलते हैं, हम पहले ही इसको डिफाइन किए थे, Q बाई डेल्टा टी, देखो Q बाई डेल्टा टी। ओके, दिस Q बाई डेल्टा टी इज कॉल्ड व्हाट, स्पेसिफिक हीट कैपेसिटी। ओके, सो Q बाई डेल्टा टी की जगह हम ये भी लिख सकते हैं, C डैश डिवाइडेड बाई M। ओके, सो हीट कैपेसिटी को अगर हम मास से डिवाइड कर देंगे सो हमको क्या मिलेगा, स्पेसिफिक हीट कैपेसिटी। ओके, सो C इज इक्वल टू Q डिवाइडेड बाई M इंटू डेल्टा टी, और इट कैन बी ऑल्सो रिटन एज C डैश बाई M। ओके, नाउ लेट्स write the SI unit of specific heat capacity। okay, so through formula we can calculate its specific heat capacity। okay, we know that what is the unit of heat, joule, and unit of mass is kg, and unit of change in temperature is Kelvin। okay, so we got the SI unit of specific heat capacity is joule per kg per Kelvin। okay, so this one is the SI unit of specific heat capacity, joule per kg per Kelvin। it can be also written as joule per kg per Kelvin। okay, sometimes they will give you in the form of like this, kilojoule per kg per Kelvin, so it can be written as 10 to the power 3 joule per kg per Kelvin। they can also write this its unit like that, joule per kg per degree Celsius। okay, so this is also unit of a specific heat capacity, but they will ask suppose SI unit of a specific heat capacity, then you have to write this one। okay, now some conversion we have to look in this, suppose 1 calorie per gram, 1 calorie per gram per degree Celsius. Suppose I have to convert this into joule per kg, joule per kg per Kelvin. Okay, suppose I have to convert it, this calorie पर ग्राम पर डिग्री सेल्सियस को हमको जूल पर केजी केल्विन में कन्वर्ट करना है. देन कैसे कन्वर्ट करेंगे? वी नो दैट 1 कैलोरी इज इक्वल टू हाउ मच जूल? 4.1 joule. Okay, and this one is gram. So suppose I have to convert this gram into kg, I have to divide it with 1000. Okay, so it, in this case we can write into 1000 into 1000. Okay, so it will come how much? 4.2 into 10 to the power 3 joule per kg per Kelvin. Okay, now again in exam they ask question like this. Suppose we have water. Okay, now water's specific heat capacity is C is equal to 4200 joule per kg Kelvin. This one is the specific heat capacity of water, which is fixed value. Okay, so what is the meaning of this? Suppose we have 1 kg of water and now suppose I have to increase this 1 kg of water temperature by 1 degree Celsius. Suppose its initial temperature is 20 degree Celsius and I have to increase its temperature 21 degree Celsius. So the amount of heat energy required to raise its temperature from 20 degree Celsius to 21 degree Celsius means 1 degree Celsius we have to increase its temperature. The amount of heat energy required is how much? 4200 joule. Okay, so Q means amount of heat required to raise the temperature of water through 1 degree Celsius, 4200 joule of heat required. So this one is the meaning of a specific heat capacity.